Hi, my name is Ian Fogarty and I'd like to talk to you about alcohols and ether. Alcohols is one of the functional groups for organic chemistry, and it's denoted by an OH. So here we have methane, part of a methane molecule, a C, and an H3, and then instead of attached to the fourth hydrogen from methane, it's attached to an O and then an H. And so we're going to give this ending an -al. It turns out that they're polar, and sometimes instead of calling it -al, we'll call it hydroxy. So this one, if I'm naming this, is going to be 1 carbon. So there's my 1 carbon, and then it's got an OH on it, and so our prefix for 1 carbon is metha. This would normally be methane except for the OH, so it's just going to be simply methane, drop the E and add OL, and so this is going to be methanol. Here we have 2 carbons with our OH, and so it's going to be 2 carbons is etha, and so that's going to be simply ethanol. 1, 2, 3. This is going to be propanol. Now here we have propanol. It's attached to carbon number 1, so we'd give the OL the smallest possible number. So that would be a 1 and a 2 and a 3. Here we'd have 1, 2, and 3. So this is also going to be propanol, but this is going to be 1 propanol, and this is going to be 2 propanol. However, we use it so often that we would call this isopropanol. So here's a 3-dimensional representation of alcohol. There's the red and the white is the OH group, and the blue and the white is the CH2 group and the CH3 group. There's a space filling model. Our methanol that we had here before is great lock deicer. It's fantastic for getting rid of ice out of your locks. Ethanol is what you might consume as drinking alcohol. It's also a great disinfectant. And then propanol and isopropanol. Isopropanol is rubbing alcohol. It's also used as a disinfectant in Lysol sprays and those kinds of things. 1 carbon, 2 carbon, 3 carbon, 4. So this is going to be like butane, but it's got my OH, so it's going to be butanol. This is also going to be butanol, but now it's going to be, sorry, not 1, 2, 3. We want to give the OH the smallest possible number. So it's going to be 2 butanol. This is going to be a butanol as well, but it's in that special tertiary shape. That's a tertiary carbon right there, and so it's going to be T-butanol. People might try and name this something else. They carbon number 1 and carbon number 2, so that you would have an ethanol, and then off of carbon number 1 you'd have a methyl group and another methyl group, so 1-dimethyl ethanol. However, there's a better name for it, and people are missing it. It would be better to give it the longest continuous carbon chain. So this should be renumbered 1, 2, and 3. So this should be 2 propanol, and then 2 methyl. Sometimes we end up in a situation where the all and something else get in conflict. So I have my ene here, and so this should be something 1, 2, 3, 4, 5, 6. So this should be a hexene, but if I think about the alcohol, it would be a 1, 2, 3, 4, 5, 6. That would be a 2-all pentanol. But how do I put the ene in there? Or it could be 2 hexene, but how to put the all in there. And so there's a couple ways of doing that. One way of doing that is to change the OH from all to hydroxy. And so if there's a conflict between, well, if I talk about the ene or do I talk about the all, we have hydroxy as a backup. So what we can do is just use the OH as a hydroxy and call it a branch. So we'd have 1, 2, 3, 4, 5, 6. And so there's my hexene. It starts on carbon number 2. There's a 2. It's trans. And so that's great. That's trans. And then I have my hydroxy off of carbon number 5. So there's a conflict between the ending and an alcohol. We can call it the alcohol a hydroxy instead. Ethers. Ethers are fantastic and wonderful. They have carbons and then an oxygen and then more carbons on either side. They're great solvents to use in a whole variety of ways, particularly in the chemical lab. However, they're also used in the legitimate and illegitimate drug trade. And the problem is that they're very volatile. They turn to gas very easily, and they're very flammable. So this one is diethyl ether because it has an ethyl group on one side and an ethyl group on the other. And this one has an isopropyl group because it's connected in an odd little way. And then an ethyl group, so this is going to be isopropyl and ether. And the E comes alphabetically in front of the P. And so ethyl isopropyl ether. Thank you very much for your time.